All right, howdy. This is Team 6. My name's Carly from Kowiak.
I'm Michelle Grauman.
And then Austin and Zach are on here as well. So our group has been tasked with the process developing an elderberry processing plant based in Guatemala. The elderberry crop is a crop that grows very well in the country of Guatemala, and so we've been tasked with the development of a concentrate product that would be sold to eventually be made into a dietary supplement in the form of a gummy. So we'll be talking about our recommended solution today. We'll go through our process overview of how this solution would be implemented to create the entire product, and then we'll go through an economic analysis that will include an equipment and machinery investment, operating cost, as well as a profit analysis. So to begin, the recommended solution that we've chosen for this project is the vacuum distillation system. We chose this system because of the benefits of being able to decrease the boiling point of the concentrate to remove the water. And so the elderberry crop is very sensitive to heat, and so by reducing the boiling point, we are lowering the level of antioxidants that are removed when we are removing the water. So the process overview is based on 100 pounds of elderberries flowing through the system each day, which isn't very much. And so the client wanted a modular system that could grow as the system grows. And so we're also working with a limited budget, which we've kept in mind in creating this system. So for the process overview, when berries come into the system, they're transferred into plastic baskets. A worker will place the berries into the basket and then bring them to an initial wash. The container shown here on the bottom right has a capacity about of 140 gallons of water, and so each day that would be filled up halfway, which would be about 70 gallons. The elderberries would be rinsed in here to remove contaminants from the field, and then the container would be sanitized daily and then refilled the next day. And so once the worker places the berries into the basket, they dip it in here, allow it to drain, and then moves to the next step. The next step would be freezing. And so when the berries are put into the freezer, they're transferred to multiple shallow sheets that are stacked in the freezer. And so it's important for them to be in a single layer. This would avoid the berries freezing together in clumps. They'll remain in the freezer for a minimum of 2 to 3 hours. They could always stay in for longer if necessary based on processing that day. But in order to be frozen, they'll remain in the freezer for about 2 to 3 hours. And this freezer goes down to about 0 degrees Fahrenheit. And so after they go through the freezer, the next worker will take them into the mechanical shaker. And so they'll be transferred back into the basket, placed into the shaker. The purpose of the shaker is to remove stems, leaves, and other debris and separate just the actual berry. And so since the berries are frozen at this point, the rigid structure further allows the stems and everything to be removed without crushing the berries or damaging them. So now I'm going to pass it to Austin for the rest of the process overview.
Yeah, so the next step of the processing involves submerging the frozen berries in another water bath, and this is going to serve 3 purposes. First, it's going to wash the berries for a second time. Second, it's going to allow us to remove the unripe berries from the ripe berries. And third, it's going to thaw the frozen berries so that they can move on to the next step in the process. The plan for this step involves dumping the frozen berries into a water bath similar to earlier in the presentation. And once the berries are allowed to settle, the unripe berries will float to the top, and a worker will use a skimmer to remove the floating berries. And once the ripe berries have thawed, they'll be removed from the bath and they're ready to move on to juicing. Next slide. So for juicing, we chose a steam juicer, and there's a couple reasons we used a steam juicer. The first is that it eliminates the toxins present in elderberries. And secondly, it allows us to extract the juice without using electricity or manual work. It also allows us to use wood burning stoves to heat the berries as the client requested. Next slide. So once we've made the juice, it's ready for concentration. Elderberries present a unique issue in that they can't be exposed to high temperatures for extended periods of time because it'll destroy the antioxidants. And for that reason, we chose to use a vacuum evaporator. Vacuum evaporator works by reducing the pressure in the vessel, which reduces the boiling point of the water and allows us to remove the water from the juice without using excessive temperatures for extended periods of time. Next slide. For packaging, our client specifically requested using 5-gallon buckets, but with the minimum supply of 100 pounds of elderberries per day, we're only expecting to produce 1.2 gallons of concentrate every day. And we didn't feel like it would be a great idea to have a half-filled bucket of concentrate sitting for several days. So for that reason, we would also like to use 1-gallon buckets when we are producing less than 5 gallons of concentrate per day. So for the byproduct utilization, our client requested sending the bagasse to local bakeries to be used in pastries, but we're producing at a minimum 22 pounds of byproduct per day. So it may be difficult to sell all of the byproduct, which Zach is going to explain later. But if we find a way to sell all of it, it could be very, very profitable. So Michelle's going to talk a little bit about the economic analysis.
So for economic analysis, we'll be going over initial investment, materials and operating cost, labor cost, and profit analysis. This is our initial investment chart. It is important to note that we did provide these costs in US dollars, but the Guatemalan currency is the quetzal. And so to go over some of the equipment types and their costs mentioned in the process flow, the automatic sifter is a total cost of $412. The blast freezer has a total cost of $1,859. We'll be needing 2 steel stock tanks at 140 gallons for a total cost of $289.90. The rotary evaporator is our most expensive cost at $4,290. The mechanical press is $132.99. We'll need 2 skimmer strainers for a total cost of $878, and we'll need 4 berry totes for a total cost of $28.40. Our total initial investment cost is $6,974.36. And these are some of our materials and operating costs. So for the material recurring costs, we'll need 5-gallon buckets. For this process, we did use 5-gallon buckets, but it's important to note that with the levels of production increasing or decreasing, this could change if we are also using 1-gallon buckets. So if we're only filling a 5-gallon bucket a fifth of the way in one day, that total cost will be 70 cents. Other operating costs include water and electricity. Water is 150 gallons per day. This number is decently low because we will only be filling the stock tanks halfway, and the total cost is $0 because we'll be using well water. The electricity average in Guatemala is about 16 cents per kilowatt hour, and our total kilowatt hours per day is 103.8. This number is also low because we only have 3 machines that run off of electricity. The total cost for electricity is $16.19, and the total cost for materials and operating is $16.89. I'll be passing it over to Zach to go over the rest of the economic analysis.
So the next concern is labor cost. We've got 4 production line employees. The first employee is the initial water bath, and then he'll take those berries to the freezer. Employee after that manages the mechanical shaker. Next employee is the steam juicer, and the last production line employee is the vacuum evaporator. These employees will work a 12-hour shift 5 days a week. We based a 5-day work week because we're not entirely sure what the cultural and religious practices are in Guatemala as far as labor is concerned. So our team felt it was safe to stick with a standard 5-day work week. Their wages are based on the average minimum wage in Guatemala, which is $1.46 an hour. So the 4 employees will cost us $70.08 a day. And then we have one manager for the whole facility because it's a relatively small operation. He'll work the same number of hours and same days a week. His wages were based on an average of similar job types in the area, making him $5.54 an hour, costing us $66.42. So the total labor cost is $136.50. Next slide, please. All right, so the profit analysis. So the facility at 100 pounds of berries will produce 1.167 gallons of concentrate per day. Based on market cost for how much an elderberry concentrate generally goes through, it's about $105 per gallon, making us a revenue of $122.54 for a single day's production. Now the berry pulp's where it gets a little tricky. We generate 22.5 pounds of it per day, and the client has requested that we sell it to the local bakeries and restaurants in the area. Our only concern is that 22.5 pounds of berry pulp is a lot to sell, considering that it's going to be used primarily for garnishes and flavoring. It's not going to be like the main substance out of whatever they're making with it. Now the berry pulp for elderberry still is fairly expensive. We found a market value averaging around $18.50. So permitting we can sell 100% of the berry pulp, that would generate $415.73 in revenue. Combined revenue from both of those is $540.27 a day. And then incorporating for costs, our profit's looking at $386.17, netting us an annual profit of $100,790.94. This gives us a payback period of just shy of 1 month, which is actually fairly attractive. However, we made an adjusted profit analysis after this, assuming we can't sell a significant portion of the berry pulp. This adjusted profit analysis is looking at just 50% of the berry pulp sold, so 11.29 pounds instead of the 23.5. If we only sell 50% of the berry pulp, that gets us $208.87 a day, dropping our total revenue to $331.41. This pushes our daily profit down to $117.31, netting us annually $46,277. Now, while that $54,000 annual decrease in profit looks like a lot, the important thing is it pushes our payback period to just under 2 months. So yes, it does decrease profits considerably. However, given the scope of this system, since it's not an incredibly large initial investment, it's still a fairly doable process, and it's still expected to make profits. Next slide. So in conclusion, our next steps, we still need to develop the risk and implementation plan. One thing that we still want to go back over with the client and maybe the Bain group is to confirm the packaging requirements. Like I think Austin mentioned, we're not always going to be producing 5 gallons, so it might not be reasonable to assume that our packaging sizes only come in 5 gallons. And then the next meeting will be April 13th at 9:45 a.m. Thank you.
Okay, good. Since we don't have a client, let's go right to the peer team. Let's get a couple of questions and a couple of comments or some mixture thereof from Team 8.
Is the production per day less than 1 gallon, or is it over a gallon?
So the production per day at a minimum is going to be 1.167 gallons. So just over a gallon.
So is there like a bigger container that they're storing that in?
So the issue we're at right now is the client had requested 5-gallon containers for packaging, but if we can't produce 5 gallons, we've got a berry concentrate that can store well in a freezer or in a chilled environment. But if you were to take it out every day to fill it up a little bit more, we're trying to figure if that would damage the actual product itself. So we're looking into trying to get smaller containers instead of using the larger ones that we may not be able to fill in a single day.
Thank you.
I think y'all's economic analysis or the profit chart was really well done. I really liked that y'all compared if y'all could sell all of the berry pulp or not. I think that was really good on y'all's part for including both options in case y'all didn't meet it.
I have a couple more. Those are good questions and comments.
Yeah, I like how that table is designed, and I liked how the discussion that Zach had about the adjusted profit, about like just kind of how you were going back and forth talking about the payback period and everything like that. I thought that was a really good discussion surrounding that.
You want to go first? Anybody else? Okay, you're leaving me and Dr. Castell all this time, so you had a chance to help him out there, teammate, by eating some of it. Here we go.
Really good job. I'm very pleased with how you present the problem. You outline the processing line. That's great. You know what it takes to make that concentrate. So great job. The only thing I would like to see, and I think you can do that in your final presentation, is provide a flow chart of the entire process line so the audience can see where is the freezer located, right, versus the juicer, which one comes first. And I was curious, what is the actual boiling point that is suggested to produce in that evaporator? I'm sure you're working with the Bain team and they have this data, but I think it's important to know how low can you go with the pressure, right, to reduce the boiling point to a temperature that doesn't affect the quality of the juice. So I was looking for that number. Remember, I always, if you took my class or taking, I always asking those numbers. I was very impressed with the fact that you provided different scenarios for the client. That's great because, as you know, he has a very wide range, a broad range of input and outputs. I wanted to ask you, what about the cost of cleaning water and disinfectants? There is a cleaning process after each day, so I think that has to be added to the cost. And where do you get this $105 cost to sell the concentrate? Where did the client tell you that?
So that was from just general market research, looking up similar products and trying to get an average of how much other items we found on the internet would go for.
Okay, so I would suggest you check back with your client because I believe he plans to sell that at a much more lower price. So the profit might not be there as early as you're saying. So I'm sure he's looking at $1 per liter cost, and you're giving me $105 for 4 liters. So check back with the client just to make sure, and of course, your analysis can adapt to any cost, but I think you need to check back with him. $105 in Guatemala might be too high for the local producers and so forth. And one more question. These prices for equipment are for U.S. vendors, or could he get an estimate about local vendors in Guatemala, or could he get the equipment donated, right? The evaporator and the freezer are very expensive. So you could suggest these options incorporate that in your analysis. Otherwise, excellent, very good, professional, excellent flow, good distribution. So congratulations.
Thank you, Dr. Castell. Yeah, this was a really good presentation. I would hold this out as an example to next year's class. This is what an A presentation looks like. You really hit all the major components of your recommended solution. It was very well presented. I was able to follow along very well. Your economic analysis hit all the major things. There's a couple things missing that I'll ask questions about, but this is a good job. Your organization, your presentation, your slides, your transitions were all good. Even the introduction, although a couple of you introduced yourselves and a couple of you kind of missed, Carly recovered really quickly and kept going. So really a nice presentation. So let me ask some questions. Let me start with Carly, because part of what we grade you on is how well you address questions. Carly, you said this is based on 100 pounds of elderberries per day. How many days of elderberries? I mean, elderberries are obviously seasonal. Is this going to be 30 days worth of work, process, or all year round? This is going to feed into the economic analysis in a minute, but how many days of 100 pounds a day can you expect?
Zach, would you be able to tell me what the yearly profit was based on? How many days a year? Could you remind me?
That was based on working days throughout the week. I'm trying to remember the exact number. It was like 252 days out of the year.
Okay. Yes, so the seasonal availability was definitely something we considered. The client didn't give us a ton of information on that. It was mainly just focus on what you could do with 100 pounds of berries a day. The initial range was from 100 to 1,000 per day, but we were focusing on just 100 as a starting point. So since the elderberry crop is super popular in Guatemala, I'm assuming that there would be enough stock to do it year round if the berries were like frozen beforehand, or if once they were cleaned and frozen, they could just be stored before they were juiced. So that's definitely something we can talk more with the client about on how it would be, if it would be just a seasonal operation or if it would be year round.
Okay, yeah, I think you're going to need to get an idea when you're determining your revenue and your annual your profit. You need to know what the annual production is going to be. So just because there are 252 working days a year or whatever you came up with doesn't mean you have 100 pounds per day. So y'all need to go back and check that. Carly, let me ask you a question again about your process. How long is the freezing time? For how long do they have to be frozen? Maybe you said that. Go back to that slide.
Yes, 1 second. So the Bain team had given us some information on like the freezing point and all of that. And so they had told us it was approximately 2 to 3 hours as a minimum. They could obviously stay in for longer. Does that answer your question?
Yes, it does. I'm sorry, I just missed it. Okay. The other question I have, and I'll just throw this out to everybody. This is what I call a small scale production model. How scalable is it? How would you scale this up? Would you have multiple process lines? Let's say you went to 500 pounds a day. Would you have 5 process lines that look like this, or would you buy larger equipment? How would you envision scaling this up?
So we actually had a discussion about that, whether we would, hire more workers and use the same equipment, or use the same equipment, or upgrade the equipment with the same amount of workers. I think that if to initially scale it up, you would need a bigger evaporator and juicer. Those are probably the most limiting factors. And then either a bigger freezer or an additional freezer. But since each project or each step of the process takes a bit of time, you probably wouldn't need a ton of more employees. For instance, like since they have to be in the freezer for 2 to 3 hours, that employee could be doing other things while it was in the freezer. So the
Okay.
main limiting factors would be the machinery and equipment.
Good. All right. Let me. Good job, Carly. Let me talk to Austin. Austin, go to your slide with the evaporation system, the evaporator. You talked about 1.3 gallons was its capacity. Now, this is a really cool looking lab scale flask thing. Is this really what the evaporator is going to look like, or is that just a placeholder?
I believe that's what it looks like.
Okay, so ultimately, what I got from your presentation is from 100 pounds a day, you're only getting about 1.2 gallons of concentrated juice per day. Is that right?
Yes, sir.
Okay, so so the evaporator how long does this evaporation process take place? I'm trying to get what's missing in your process is the time. I don't know if you can get through 100 pounds a day with the time involved. You got to freeze it for 2 to 3 hours. I don't know how long this is going to take. So can you give me an idea of the time of some of these parts of the process?
For evaporation, I don't have a specific time, and we are going to work to find a specific time for it. What we do know is that it evaporates 1 milliliter of water per minute. So I'm sure that's a calculation we need to make to know specifically how quickly it will make the concentrate from the juice.
Okay, and maybe that kind of goes back to Dr. Castell's comment. You need to have the flow chart with each of these parts of the process with a time involved as well. Okay, good. Go to your next slide. I'm looking for the one with byproducts. Okay, so the byproduct is the bagasse, basically what's left over from the concentrated from the berries after you squeeze out the juice, right?
Yes, sir.
That's not it, is it? I mean, you basically got that picture saying you're going to sell at the bakeries. I would probably not use that picture. I would probably try to get a picture of some kind of elderberry byproduct. Anyway, that's a minor comment. But good job with juicing up your slides like this. Okay, let's go to Michelle. How am I doing on time? Got a minute. Yeah, Michelle, your economic analysis. Let's go to your first slide here. This is really nice, well done. Obviously, you mentioned that in Guatemala they have different units of currency, but for ease of understanding, we're going to do it in dollars. That's fine. What are some things that might be missing here? How about the shipping costs? Transportation costs. This is all going to be part of that initial investment. I'm kind of nitpicking here. I think you hit the major components here, but that's pretty well done. So, Michelle, any idea, any consideration of the shipping costs?
No, we have not considered the shipping cost yet.
And then also the installation. There's going to be some labor involved with that. Although I think what you're assuming is it's going to come to the plant and their workers are going to install that. So their labor would be absorbed in their own internal workings there. So, okay, let me go to Zach. Zach, nice job on the labor. As during Michelle's presentation, particularly on her second slide, I was looking for labor. Where is it? Well, Zach came through and labor. So I was wondering how many employees. You answered that. Wow, they're working 12 hours a day. And my other question was, how many days per year? I think you said 250 something. Tell me how many days per year, and how'd you come up with that?
Yes, sir. So based on the 5-day work week, excluding obviously a Saturday and Sunday weekend, and then we did not incorporate holidays because, again, that's one of the cultural things that our team doesn't know what Guatemala recognizes for holidays. So just assuming a 5-day work week, I want to say that was about 252 days out of a year.
And that's a good number for calculation, so no problem. Go to your next slide. This is the slide it was probably the most confusing, although I figured it out. You've got a column over on the right of revenue, but then you've got a row that says profit per day. So I would have probably had one table for revenue and another table for profit, showing me how you calculated the profit. It's obviously, revenue minus expenses, but I had to remember your previous numbers to come up with that. So that could have been a little bit more clear. And then annual profit, you probably could have had parentheses that said days of operation. But again, I think this is all going to be dependent on how many, elderberries they can actually produce. I think you're making some assumptions here that are at this point are a risk. I say that word with a hint toward your next part of the process, risk analysis. What if they don't come up with, 250, let's see, 100 times 250 days? That's like 2,500 pounds of elderberries. So that's a lot. So obviously your payback period looks pretty optimistic. I think that may be quiet. I also like the way that you, on your next slide, and one of the, I think Blaine mentioned this, or maybe Amelie did, go back one. The berry pulp is not really the product. It's a byproduct, yet it makes up a large part of the revenue. That's a risk because I'm not sure that there's a big market for that. So I would probably include that as a risk, and a way to mitigate that risk, I'm just telling you one way you might solve this problem is research how to make a value-added product out of that pulp. Instead of giving it to a bakery and expect them to come up with something, y'all, not your team maybe, but your client, come up with some ways to make a product out of the berry pulp. Unless, of course, the bakery's already got something figured out and there's a demand for it. But that is a risk. Your byproduct has more of a revenue, is more of a revenue generator in this model than your concentrate because you don't have a large volume of your primary product. So think about that. Anyway, good presentation.